Betelgeuse, the colossal red supergiant blazing at the shoulder of Orion, just experienced a staggering 150% surge in brightness, an enigmatic pulse that has astronomers buzzing with excitement. This cosmic titan has a history of erratic behavior, with recent outbursts suggesting it could be on the brink of a supernova explosion. But when will it happen? What does this mean for our understanding of the universe? As we delve into the mysteries surrounding this giant, we'll uncover how Betelgeuse's unprecedented brightness changes are rewriting what we know about stars and bringing us closer to an astronomical spectacle that could light up our sky for weeks. The recent brightening surge. In a recent and stunning astronomical event, the James Webb Space Telescope has captured a significant increase in the brightness of Betelgeuse, one of the most well-known stars in our night sky. This red supergiant, typically noted for its steady glow on the shoulder of the Orion constellation, has recently surged to become the seventh brightest star visible from Earth. The brightness of Betelgeuse has peaked at an astonishing 150% above its usual luminosity. This sudden and unexpected brightening of Betelgeuse offers a unique spectacle for both amateur stargazers and professional astronomers. Positioned in a constellation familiar to many, its enhanced brilliance makes it an even more striking feature in the night sky. The increased brightness is not just a trivial change. It represents significant and dynamic processes occurring in the star's life cycle. Such a surge in luminosity could be linked to changes in the star's surface temperature, size, or radiative processes, showcasing the unpredictable nature of these celestial giants. As the star currently ranks as the seventh brightest, its prominence in the sky is a call to observers and scientists to watch closely. Each observation and data point collected helps in piecing together the complex life story of stars like Betelgeuse. The James Webb Space Telescope, with its advanced capabilities, continues to monitor these changes, providing crucial insights into the behavior of stars on the brink of their evolutionary shifts. This event not only enriches our understanding of stellar dynamics, but also enhances the nightly spectacle for skywatchers around the globe. Supernova anticipation. As the enigmatic red supergiant Betelgeuse continues to dazzle stargazers and astronomers alike, anticipation is mounting over the possibility of it going supernova, a stellar explosion that can offer a spectacle unlike any other seen in our lifetimes. Betelgeuse, a behemoth star nearing the end of its life, has sparked a wave of speculation due to its unusual and dramatic fluctuations in brightness. This has led many to wonder, are we on the brink of witnessing a supernova? Experts in the field are closely monitoring Betelgeuse, predicting that it might explode into a supernova within the next few decades. This potential timeline, however, contrasts starkly with NASA's more conservative estimate, which suggests that Betelgeuse's supernova event may not occur for another 100,000 years. This disparity in predictions underscores the complexities and uncertainties inherent in studying such colossal celestial phenomena. The prospect of Betelgeuse's supernova has not only captivated the scientific community, but has also permeated popular discussions. The idea that we could soon witness one of the most significant events in our galaxy, an event so bright that it could outshine the moon and be visible during daylight hours, stirs a blend of excitement and awe. This anticipation is further fueled by our limited understanding of supernovae, as each observation provides critical data that can redefine what we know about the life cycle of stars. Thus, the watchful eyes of the world remain fixed on Betelgeuse, eagerly awaiting any signs that may hint at its imminent transformation. Whether this spectacular event occurs in the near future or millennia from now, the ongoing study of Betelgeuse offers invaluable insights into the final days of a star's life. Historical brightness patterns. Betelgeuse's erratic luminary ballet has fascinated skywatchers across the millennia. From the indigenous Australians to the ancient Greeks, the star's periodic brightening and fading have been meticulously observed and documented, embedding Betelgeuse deeply into cultural lore and astronomical study alike. Traditionally, this red supergiant exhibited a predictable brightness cycle lasting approximately 400 days. However, recent observations have painted a different picture, revealing a shift to a much shorter 130-day cycle. This significant change in Betelgeuse's behavior marks an atypical deviation from its historic patterns. What could possibly cause such a dramatic alteration in its cycle? This question captivates astronomers and adds a layer of mystery to an already enigmatic celestial body. The shift suggests an underlying change in the star's internal processes or external influences that we are yet to fully understand. The implications of these rapid cycles are profound, both for our theoretical understanding of stellar physics and for the practical monitoring of Betelgeuse. As we continue to observe this star, each cycle of brightening and dimming could bring us closer to unraveling the secrets of its celestial mechanics and perhaps predicting its ultimate fate. For now, the rapid changes serve as a celestial puzzle, connecting the curiosity of ancient civilizations with the high-tech investigations of modern astronomy. The Great Dimming Event. In late 2019, the astronomy community was abuzz as Betelgeuse, one of the most well-known stars in the night sky, began to exhibit some highly unusual behavior. This red supergiant star, famous for its brilliant reddish hue and prominent position in the Orion constellation, unexpectedly dimmed by an astonishing 60%. This phenomenon, quickly dubbed the Great Dimming, sparked a wave of speculation among scientists and stargazers alike, many of whom wondered if Betelgeuse was about to go supernova. The dimming was so significant that it was clearly visible even to casual observers, marking a stark change from the star's typically bright appearance. The sudden shift led to numerous theories about the star's imminent death and transformation into a supernova, which would have been a spectacle visible across vast distances in the galaxy. However, as astronomers monitored the star more closely using the world's most advanced telescopes, a different explanation emerged. It was discovered that the Great Dimming was not a sign of impending supernova, but rather the result of a colossal surface eruption on Betelgeuse. This massive explosion had expelled a significant cloud of dust away from the star's surface. The cloud was large enough to obscure the light coming from Betelgeuse, leading to its dramatically reduced luminosity as observed from Earth. This finding was crucial as it not only provided a rational explanation for the dimming, but also offered a rare insight into the kinds of surface activities that can occur on red supergiants like Betelgeuse. The Great Dimming served as a reminder of the dynamic and ever-changing nature of stars, regardless of their age or size. It highlighted the complex interplay of forces operating in these colossal celestial bodies and how they can lead to spectacular, if misunderstood, events that can momentarily trick us into believing that a star's end is near. Moreover, this episode allowed astronomers to study the mechanisms behind such massive ejections and how they affect the star's behavior and evolution. Understanding these processes is vital for predicting the life cycles of similar stars and preparing for the actual supernova events that one day will light up our skies. Star size and structure. Imagine, if you will, placing Betelgeuse at the center of our solar system. This colossal red supergiant would not merely loom large in our sky. It would engulf it, extending beyond Mars and reaching all the way past Jupiter. This staggering size isn't just for show, it fundamentally affects how Betelgeuse behaves as a star. Betelgeuse is classified as a red supergiant, a type of star that has exhausted the hydrogen in its core and expanded massively as a result. The sheer scale of Betelgeuse can be hard to comprehend. In comparison, if our Sun, a mere speck in size against the backdrop of Betelgeuse, were to suddenly expand to the red supergiant's proportions, it would swallow Mercury, Venus, Earth, and Mars, creating a catastrophic end for our planet. But why does this immensity lead to increased variability? The answer lies in the star's unstable nature. The outer layers of Betelgeuse are only loosely bound to its core due to its vast radius and the relatively low gravitational pull at its surface compared to smaller, more compact stars. This causes the star to pulsate irregularly, significantly changing its brightness as seen from Earth. Additionally, this pulsation allows large convective cells to form and move hot gas from deep inside the star to the surface. When this hot gas reaches the outer layers, it cools and sinks back toward the core, a stellar conveyor belt of sorts that not only stirs the star's atmosphere, but also contributes to the star's periodic dimming and brightening. Understanding Betelgeuse's structure gives astronomers critical clues about the life cycles of red supergiants and how such stars end their lives. Given Betelgeuse's advanced age and bloated size, it stands as a perfect laboratory for studying the final stages before a star goes supernova, offering insights not just into the star itself, but into the broader mechanisms governing stellar evolution. Scientific observations and tools. In our quest to unravel the mysteries of the cosmos, the role of advanced astronomical observatories cannot be overstated. Tools like the James Webb Space Telescope, the Hubble Space Telescope, and the Very Large Telescope stand as pillars of modern astronomy, providing us with the essential data needed to decode the behavior and structural changes of stars like Betelgeuse. The James Webb Space Telescope, with its unparalleled infrared sensitivity, allows astronomers to peer into the dusty veils surrounding stars, revealing hidden structures and temperatures that were once beyond our reach. This ability is crucial when studying a star like Betelgeuse, which often shrouds itself in a cloud of its own making. Meanwhile, the Hubble Space Telescope continues to offer invaluable support with its high-resolution capabilities. Its observations have helped track changes in Betelgeuse's size and surface activity over the years, providing a clearer picture of its pulsations and occasional ejections of material. The Very Large Telescope, situated in the arid deserts of Chile, complements these observations with its own unique capabilities. It employs a suite of instruments that can capture high-resolution images and spectra, allowing scientists to observe the star in different light spectrums. This multifaceted approach is essential, as the different wavelengths can tell us about various aspects of the star's surface and atmospheric conditions. The synergy of these observatories has turned Betelgeuse into one of the best-studied stars in our night sky. Each telescope contributes a piece to the puzzle, from mapping the star's vast surface to monitoring its light fluctuations and spectral signatures. This collaborative global effort not only enhances our understanding of Betelgeuse, but also sets the stage for understanding other similar stars across the galaxy. Through the lenses of these powerful observatories, we continue to witness the life story of one of the most intriguing stars visible to the naked eye. Astrophysicist Insights. As we delve deeper into the mysterious life cycle of Betelgeuse, it's crucial to consider the insights from renowned astrophysicist Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics. Dupree's research into this massive red supergiant reveals that Betelgeuse might currently be in a pivotal phase of its stellar evolution. According to her observations, the star could be nearing the end of its core carbon burning stage, a critical phase just before a star transitions into a supernova. The core carbon burning stage is one where a star like Betelgeuse converts its core carbon into heavier elements such as oxygen and magnesium. This process is a precursor to the collapse of the star's core, which could trigger the explosive and spectacular demise known as a supernova. Dupree suggests that this phase could conclude within the next few decades, positioning Betelgeuse on the brink of an epic cosmic event. What's particularly fascinating is how this assessment aligns with the unusual behavior we've observed from Betelgeuse in recent years. The increased frequency and intensity of its brightness fluctuations could be signaling that these internal transformative processes are more advanced than previously understood. This insight not only helps astronomers predict the star's future, but also offers a rare observational opportunity to study the pre-supernova activities in real time, a chance to witness firsthand the final chapters in the life of a star destined to end in a blaze of glory. Historical expectations. In the cosmic arena, our understanding of supernovae has been dramatically reshaped over recent decades. It was once firmly believed that only red supergiants were capable of culminating their stellar life cycles in the dramatic explosions known as supernovae. This view held sway in the astronomical community, grounding our predictions and theories in a framework that seemed unshakable, until 1987, that is. The year 1987 marked a pivotal shift in cosmic perceptions with the surprise supernova of a blue giant. This event sent shockwaves through the scientific community, challenging the long-held belief restricted to red supergiants. The blue giant, significantly hotter and more massive than its red counterparts, defied the expectations by undergoing a supernova, thereby expanding the scope of our understanding of stellar death. This paradigm shift not only widened our horizons regarding which stars could potentially go supernova, but also deepened our curiosity about the life cycles of stars across the spectrum. It underscored a fundamental lesson in astronomy. The universe often holds surprises that defy our expectations and assumptions. Each such event not only adds a new layer to our understanding, but also humbles us, reminding us of the vastness and the mystery of the cosmos that surrounds us. As we continue to observe and study stars like Betelgeuse, we do so with an awareness that what we know is only a fraction of what there is to learn, and what we expect is not always what occurs. Neutrino signals. In the cosmic ballet of the universe, neutrinos, those tiny, nearly massless particles, play a crucial yet often overlooked role. As Betelgeuse inches closer to its dramatic finale as a supernova, it's not just the visible light that will herald its cataclysmic end. Enter the neutrinos, ghost-like particles that rarely interact with matter. These particles could be the earliest messengers of Betelgeuse's impending supernova, providing a crucial heads-up before any visual confirmation is possible. Neutrinos are released in vast quantities during the core collapse of a supernova, a moment when the star's core implodes under its own gravitational pull, moments before the outer layers explode. The fascinating aspect of these particles is their ability to escape from the dense core of the star almost immediately after the collapse begins, traveling through space at nearly the speed of light. This means that neutrinos can reach Earth hours, perhaps even days, before the light from the supernova itself, which can get delayed as it bounces around within the exploding star. For astronomers and astrophysicists, detecting these neutrinos would not only signal that Betelgeuse has finally gone supernova, but also provide invaluable data about the processes occurring within the star's core in its last moments. Around the globe, detectors like the Super Kamiokande in Japan or the Ice Cube Observatory at the South Pole stand ready to catch these elusive particles. The detection of neutrinos from Betelgeuse would be a monumental event, marking only the second time in history that neutrinos from a supernova have been detected, the first being from supernova 1987A, which provided key insights into the life cycle of massive stars. As we monitor Betelgeuse's erratic behavior and shifting luminosity, the watch for neutrinos continues in earnest. These particles may soon serve as the silent heralds of one of the most significant astronomical events of our time, providing a precious few hours warning that a supernova spectacle is about to illuminate the heavens. This early warning could catalyze a flurry of scientific activity, with telescopes across the Earth poised to capture every moment of this stellar explosion in unprecedented detail. Thus, while Betelgeuse's light will fade, its legacy will shine brightly in the annals of astronomical discovery, enhanced by the ghostly glow of neutrinos. Potential impact of supernova. Imagine a day when you look up at the sky and see something brighter than Venus, bright enough to cast shadows on the ground at night. This isn't a scene from a science fiction movie. It's a very real possibility that could occur when Betelgeuse, one of the night sky's most notable stars, goes supernova. Betelgeuse, a massive red supergiant, is nearing the end of its life, and its eventual explosion as a supernova will be a sight to behold. The sheer magnitude of this event is hard to fathom. For context, Venus, often the brightest object in the night sky after the moon, can sometimes be visible during the day. Betelgeuse's supernova, however, will outshine Venus dramatically. This incredible luminosity means that for a period, possibly weeks, Betelgeuse will be visible both during the day and night, turning from a faint star seen in a dark night sky to a celestial beacon visible even under the sun's glare. What's even more fascinating is that despite its formidable appearance and intensity, this supernova poses no direct threat to Earth. The distance of Betelgeuse from our planet ensures that while the spectacle will be stunningly bright, it will not affect our environment or health. Instead, it offers a unique, harmless viewing opportunity that combines the thrill of a once-in-a-lifetime astronomical event with the safety of an ordinary celestial observation. For those worried about potential dangers, it's reassuring to know that while supernovae can emit harmful gamma rays and other energetic emissions, Betelgeuse's distance of about 650 light-years is enough to dilute these effects to negligible levels. The most impactful part of this event for us on Earth will be its breathtaking visibility and the way it lights up the sky, a phenomenon that will allow everyone around the globe to witness astronomical history in the making. In sum, Betelgeuse's dramatic changes offer an unprecedented glimpse into the late stages of red supergiants, refining our knowledge of stellar evolution and supernova mechanisms. By studying its unpredictable behavior, we uncover new insights into the universe's grand cycles, ultimately enriching our understanding of cosmic phenomena. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.